In the previous video, we looked at what is a multiple regression model and the relationship between the multiple regression model and the estimated multiple regression equation. Also, we try to know how can we apply the multiple regression model to answer our research question, and how can we use the model to examine our research hypothesis. So please spend more time on the previous video before you move to this one. So in this video, we will look at, once we know how can we use our regression equation to analyze the research hypothesis, we want to see how can we exactly get the number, the estimate for B0, B1, B2. And so in this video, we will learn how to use Excel to get the answer. So the whole estimation process is following like this. So we first got our multiple regression model. So you will find all the parameters here are Greek letter beta. So we don't know the value for those betas. And because of those beta, we have built up the relationship between the x and y. Then, in order to get the value for betas, and we will have create our survey or collect the sample, and we'll have the sample data. And based on our sample data, we can estimate our regression equation and get a value for B0, B1, and to BP. And so the sample statistics are B0 to BP. Then we know the value for B0, B1 until BP, and we think they are the estimate for beta 0, beta 1, beta 2, and beta P. So again, we want to know the population model, but we have no idea about that. Then we go to the sample. Based on the sample, we can get an estimated multiple regression equation, which we will consider those sample statistics are the best estimate for our population parameters beta 0, beta 1, and beta P. So the method we will use actually is the method we use for the simple linear regression model called least square criterion. So what we are doing is we are trying to minimize the distance from each observation to the estimated value. So you can think about if the yi equal to the estimated y hat, and the least square criterion will be equal to 0, which will be the minimum value. So at that point, you can also find that all the observation equal to the estimated value through our model. So our model has the best fit. So obviously, it cannot be. We cannot ever. It's really hard for us to get this criterion equal to 0. What we can do is we're trying to minimize this objective function. So the computation of coefficient values, so the formula for the regression coefficient B0 to BP involve the use of the matrix algebra. We will rely on computer software package to perform the calculation. So if you go to learn a higher level of statistics, you will have chance to know how to use the matrix algebra to calculate the B0 to BP. So in our class, we will just use the Excel to help us to get the final answer. So the formula for the regression coefficient B0 to BP involve using the matrix algebra. We will rely on the computer software package to perform the calculation. The emphasis will be on how to interpret the computer output rather than how to make the multiple regression computation. So in the simple linear regression model, we do have a lot of exercise on how to compute those B0 and B1. However, when we move to the multiple regression equation, and what we want to do is first find the proper statistic from the Excel output. The second is once you get the output and find the proper statistics, and I want you to do the proper interpretation. So please pay attention on finding the statistics and the interpretation. So let's using the example to illustrate how can we using the Excel to get the our regression equation, and based on those output, we will do the hypothesis significance tests and the prediction. So the problem is about the SPAR club. So the owner of the large chain of health spa has selected 8 of her smaller clubs for a test in which she varies the size of the newspaper ads and the amount of the initiative fee discount to see how this might affect the number of the prospective members who visit each club during the following week. By looking at these business cases, you should have idea that the y variable, the dependent variable, is the number of the new customers. Because certain action this club implemented, it can affect the number of the new members. So they are thinking the size of the newspaper ads can affect the number of the new members and also the amount of the initiative fee discount. And so we will use, obviously from this case study, we will know we have the number of the new member as our dependent variable. The size of the news ads is the first predictory variable, or the first independent variable. And the amount of the initiative fee discount, the amount of the discount will be our second explanatory variable, or the second independent variable. So now let's look at the detail of the data set. So we totally have 8 clubs, and the 8 clubs collect their new visitors and the number, and also at the same time record the size of the ads and also the amount of the discount. So this is our original data set. So the first we want to learn is how can we use Excel to get our reports. So if you look at the Excel file I attach on this week's this section, and you will find this is our original data set. So the first column is the number of the observation. We have 8 observations. And the second column is a value for a y variable, the number of new visitors. And the third column, column C, is the size of the advertisements. So this is our first predictory variable. And the column D is the discount amount, so which is our second predictory variable, or our second independent variable. So we want to use Excel to get our analysis report. So first, click Data tab, and then you will find Data Analysis. Again, if you cannot find the data analysis, you need to go back to look at the last week's video on how to add the data analysis to your Excel. Then you click the data analysis. Now you try to find there is a command called regression, and choose the regression and click OK. So we have Y range, X range, and label, confidence interval, and constant 0. So this area is called input area, and what you will do is you will let the Excel know where is your original data set. And the second area here is the output options. So you need to let computer know where you want to place your regression analysis output. And then we will learn later of this chapter, we'll learn the residual analysis. So here is the residual plot we will use to validate our model. And normal probability plot is here, and we also use it to validate our model, so which we will talk about at the end of this chapter. But now let's first choose our input range. So first, the input Y range is our B column, and we will also include the first cell, which is our labels. So which means you need to first check the labels. Then click this little icon and select the whole B column from B1 to B9 and click this little icon. Then click this, now we can choose the input X range. So when we are working on the simple linear regression model, we only have one X, so we only choose one column. But in the multiple regression model, we will have more than one X, so you will choose all the column which will be considered as our X variables. Then click this little icon, and we will select C and D column. So we will from C1 to D, we will from C1 to D9. So both columns were selected as our X range. We've already checked the labels because the first row is not the number, it's the labels. And then we will put our regression output in a new page called regression. It's a good habit to name your new worksheet based on what kind of output you will have. And select the residual plot, standardized residual, line fitted plot, normal probability plot. So in this part of the video, we don't need to really worry about the residual plot and the normal probability plot because all those plots will be used to validate our model, which we'll learn at the end of the chapter. But I still require you to check them so that when we move to the end of this chapter, we will just focus on analyzing those plots. So now we can click OK. Now we will have totally 5 different plots, and you don't need to worry about this part. Now let's focus on this area. So this area, we have 3 different tables as I mentioned in the simple linear regression model, and you will find that the layout are exactly the same except in the regression equation area. Before we only have 2 row. One is intercept, another row is for the x. Now we have 3 rows: intercept, add column, discount amount. So the reason we have 3 rows because besides the y-intercept b0, we have we have 2 axes. One is add column size and another is a discount amount. So each row corresponding to 1x or 1 beta. So the first add column is our beta 1 and discount amount is our beta 2. So now we will focus on this part of the Excel output and try to recognize the statistic we've learned in our class. So now let's go back to look at our question. So suppose we believe that the number of customer y is related to the size of the advertisement and the discount amount x2 by the following regression model. So this is a regression model. If you want to ask me why, what I can say is this is model. So this format is already decided by the statisticians. You cannot question on this linear relationship. So the y is the number of the customer, x1 the size of the advertisement, x2 is the discount amount. So we have our input data, which we already see, and now we use the Excel get our least square output. So we have B1, B0, BR square, and etc. So this is I copy paste from what we just got from our Excel. So we will first write down our regression equation. So as similar as a simple linear regression model, the regression equation is coming from the third part of our Excel output. So the interception between the coefficient corresponding to intercept 10.687318 is our B0. So the y hat equal to 10.68730. And our B1 is our the coefficient corresponding to the x column inches is 2.1569, and our coefficient corresponding to discount amount is 0.042. So we write down this equation, we call it the regression equation. So the next, how can we interpret the regression coefficient? So in multiple regression analysis, we interpret each regression coefficient as follows. So we can think this as our interpretation formula. So beta I represents an estimate of the change in y corresponding to a 1 unit increase in xi when all other independent variables are held constant. So first, you need to really pay attention on in other independent variables are held constant. We only talk about beta I. We only consider the change of the corresponding independent variable and treat another independent variables as constant. So let's look at our B1 from our equation, 2.157. So that means for each column inch of ads she buys, she can expect an average of 2.157 new customers when discount fee is held constant. So first, we know the B1 is corresponding to our the size of the advertisement. So if she increase 1 inch of the advertisement, and we will expect an average of 2.157 new customer. The new members is the value for y variable. And again, don't forget the last phrase, when discount fee is held constant. So now let's look at how can we interpret the B2. So B2 equal to 0.042. So that means for each $100 she allows in membership discount, she can expect an average of 4.2 new members, given the amount of the ads does not change. So in next video, we will look at how can we find the SST, SSR, SE from the Excel output. At the same time, we want to know how can we calculate a coefficient of determination.